Is that it? Is that all we get? Anything else jump out at you? Anybody else? Yes?
6 feet more than twice the width.
All right, good. Students definitely gravitate towards that because normally by the time you're doing this kind of problem, you've been drilled with modeling situations, right? Like 3 more. If Sally was 3 years older than Bill, how old is Bill? I love that question. Sally is 3 years older than Bill. How old is Bill?
3 years older than Sally.
Exactly, good. I like that. That's my smart ass answer. I like that. That's what I would have said if I was in the class. But what do we do in algebra when we don't know a value?
Equations.
Yeah, I'm going to call it B for Bill,
Oh.
right? Or you could have called it X. You could have called it happy face. You could have called it Greek letters. Whatever the shit. You just need a symbol in the place of the thing you don't know. Everybody with me? Sally is 3 years older than Bill. Does everybody understand why I had to identify Bill's age first? Not necessarily, but still, Sally's 3 more than Bill. So if I knew how old Bill is, I definitely know how old Sally is immediately, right? Well, how old did we just say Bill is? You can do it, you can do it. We just said it. I just said it. How old is Bill? B years old. This is, all right, let me step back a second. Some of you guys just came in the room and like, this shit. So this is the thing about math that students have to get over quickly with algebra, is if I don't know what something is, we sort of pretend like we do. We give it a letter, and then whatever I would have done with that value, I do the same thing with the letter. It's just kind of keeping track of all the stuff I have to do eventually if somebody ever frickin' tells me how old Bill is. So if Bill is B years old and Sally is 3 years older, how old is Sally? B plus 3. Let me stop for a minute. You guys doing all right with that? Does that sound familiar? Those kind of problems? Okay. How old are either one? I don't know. We now have a model of their ages, and it represents the relationship between the two. We don't know what either one is, but we have a model for what to do if somebody came along and told me something, right? So up here, 6 feet more than twice. The length is 6 feet more than twice the width. So what would you need to give a value to, a letter, first? All right, let me stop for a second. I don't know how you guys are feeling over here. You guys all right? Does that make sense? So algebra is not the only way to do this problem. Do you guys understand that if I knew the width, I know everything else? Now the perimeter is supposed to be 228, but can somebody just give me a number for the width? Just give me a number.
X.
No. A number.
8.
Say again?
8.
8. All right. If the width is 8, what's the length? Right? If you know the width, you got to know the length. If the width is 8. Say again, sir. Yeah, if the width is 8, then the length will be twice that. 16 plus 6 is 22. I like it. So is that the answer? What would that perimeter be? What would the perimeter of that be?
Less than 228.
True. Now be a little more specific.
60.
Yeah, that's 30. And then that's only halfway around, right? All right, let me stop for a minute. Let me stop. I want everybody with me. If that's a little too much algebra for the beginning of a Thursday morning, it's not even the beginning. It might be, maybe this is the beginning for some of us. Yeah, so that would definitely be 30 feet halfway. Is that cool? And then twice that to get all the way around. Does that make sense so far? Are you cool with?
No, it's just that I just don't know the work of it.
Now listen. We're investigating the problem. And this is what we're going to focus a little more on. I'm going to want you guys to understand all the methods we could use. But as an elementary school teacher, you're going to be focused on thought process, almost more than anything else. Because if they don't even know, so it's interesting. especially when I'm doing word problems. And any level of math I teach, if the student doesn't even know what they could try, how would they ever come up with it on their own, right? So it's kind of good to show a lot of different ways to do a problem to see what makes sense. And of course, a big deal with some of what we're going to do this semester is, what are the connections between all the different ways? If there are multiple ways that work, they must be connected somehow. They must be addressing the same idea. All right, let me make sure you guys are with me. All right. Now, is the problem with what I've written over here the fact that where the hell did his numbers come from? Is that part of the problem? Okay. Where did that number come from? What am I doing? What is this process? Anybody know what the process is that I just used? We just identified a possible value for the width. We saw what the length would be. We saw that's not the right answer.
Guess and check.
Guess and check. Guess and test. I know. This book calls it guess and test. I'm used to calling it guess and check. So I'm probably going to say both. All right, let me stop for a minute. You could continue this, couldn't you? Obviously, what's going to happen to the width? It can't be 8. It's got to be bigger. Cool. Do you want to do that?
No, not really.
Not really. Unless you really had to and you like really hated algebra, then you'd have to do this. Let me guess again. What if the answer was 103.79? Would you ever get it that way? Probably, maybe? Probably not. Are you guys kind of? That's where algebra comes in and saves your ass. It says, oh, you don't know that? I've got a process, so you don't have to take guesses forever until you go insane. So instead of doing this, let's just call W W. The width is W. Right? The width is W. Why are you up on the board, Jeff? Because I want to be. I want to try to be up here, but I like the board. If the width is W, what's the length then?
L.
No.
If
you give, real quick, if you give the length a different letter, that means it's independent from the width. Is it independent from the width? Isn't the length 6 feet more than twice the width? Well, what's twice that?
2W.
2W, and then 6 feet more than that. Yeah. Get out of there. Colon. Right? And this is a specific instance of this relationship. So if the width was 10, this would be 10 and 26. Still not enough, right? So it's sort of like a Price is Right game. You guys ever watch Price? Higher, lower, higher? Yes, maybe? That was me when I was a little kid when I was pretending to be sick. I'd watch the Price. Now, here's the thing. Last thing I'll say about this, because then we got to get into the real nitty-gritty stuff of other ways to do this. To finish this bad boy out, what I would almost always get, to be honest, what I almost always get from algebra students is I'll get somebody writes this equation. What was it there? Anybody identify what's wrong with that? Yes?
It's just the length, not the length.
Yes! So what is a step that would help, considering this is a geometrical problem, right? What is a step that we could use to help us that I didn't use yet? This is a geometrical problem.
Creating an equation to find the perimeter?
Yes, but to help me get there, I can
Diagram.
draw a picture, right? So this thing, if you draw a picture and label some stuff, there's W, there's 2W plus 6, and I give my left arm to be ambidextrous, but I'm not, right? And sometimes I'll get somebody say this, which is a little better, but again, that's only how far? Halfway. So then you go, oh shoot, I need 2 of these and 2 of those. And that would be your equation, right? Twice W plus twice this. Now watch this. Does anyone get this? If I did write W plus 2W plus 6, that's not equal to 228. That's equal to 114, and that's a beautiful little equation that will give you the same answer. Does anyone get that? I probably pushed this a little too far, yes.
Wait, what?
That last thing I did. Do you understand that?
No.
All right. Let me see. Let me come back up here. So I'm more centered. So what we've got, I will always have somebody do this because they focus on 6 more than twice and they go, oh, we've been talking about that shit. I know how to write 6 more than twice something. I'm sorry. Thank you. Yeah, this thing is a little off. See? It's way off. What are you doing? All right, that'd be good. Okay. All right, so I always have somebody write this because they see 6 more than twice, and they go, great, I got that, equals 228, and that's no thought at all. It's just purely trying to get to the answer quickly.
Can we just do like -6?
Wait. If you solve an equation that is bogus to begin with, you won't ever get the right answer. Why is this equation bogus? Does it go all the way around the picture? So again, we know that our width, we're going to call it W because we have no idea what it is, but I have to know what it is to be able to build the length. Maybe. So then the length is 6 more than twice the width. And then, since this is a geometrical problem, drawing a picture is a smart move. Some kind of a visual anchor. Right? Everything okay over there? Yeah? Okay. So if you draw a picture and you label it, dang, I'm really zoomed in, that's one thing. There we go. Then you'll realize what you have to do. The full equation would be 2 W's, right? 2 W's plus 2W plus 6's equals 228. That's fine if you do that. I just wanted to see if anybody realized you could just go W plus 2W plus 6. That's halfway. So of course it would be 114 if I only went halfway.
Do we have to do the whole, how do I say this, the cross, the...
Do you have to do what now? Are you talking about what to do right here?
Yeah.
Yeah, then you have to solve this. Yes, I like it. So one method you could use is the first method we tried, which is guess and check, or guess and test. That would take a while, and that would really suck if the answer was actually 72.97 or something. Oh my God. Right? So a much better way to do it is algebra, because everybody hates algebra, but algebra is just like, I got you, man. If you don't know some shit, I'm going to give you some stuff to call it. You can do stuff with it. Yay! Right? If I knew the width and if I knew the length, wouldn't I just add 2 widths and 2 lengths to get the whole way around? Of course I would. So this is exactly what I would do if I knew what the hell they were. So if I just give them names that represent the relationships, I do that with them. That's all algebra is. All right, I like it. Okay. So then you got to remember how to do some algebra, right?
Wouldn't that be, if what I got for was 4W squared plus 16W plus 12? Because of course because...
Oh, dude. All right. What's the only thing that 2W plus 6 is multiplying by? The 2. That's it.
Oh.
That is adding 2W. If I wanted to FOIL, I would have to have parentheses around this bad boy.
Oh.
Okay, I like it. And again, don't suddenly freak out. You don't have to suddenly remember all of algebra. I'm just doing this just to see if it kind of ticks off some stuff in your memory. Okay, maybe. Okay. So then what would this really be?
4W.
Plus 12, I like it. And then what?
Combine like terms.
Yep. So we got 2 W's and 4 W's, so why wouldn't I just say 6 W's? Right?
Then can we subtract 12?
Hell yeah.
Then divide 6W?
Yeah, divide what now?
Divide like 216 divided by 6.
Good, by 6. I like it. So W is,
36.
what is it, 36? 36 what?
Feet.
Feet. And now look, we were smart. Would you circle that and go to the next problem?
No.
Why not?
Yeah,
Yeah, the width.
Because I want to know the dimensions. I want to know both the width and the length. And the nice thing is I've identified for myself exactly what the hell to do. If I know what W is, which now we know what it is, so then what's the length?
78.
78.
How did we get 78?
Oh,
Oh, wait.
we know what the width is,
Oh,
so twice that plus 6. Yeah.
36 plus 6, 78.
How many rectangles exist where the length is twice the width plus 6? How many rectangles exist like that? Well, how many values for W could you pick? Infinite. That's the right way to infinite. Right? So there's an infinite number of rectangles that have that relationship. They just get bigger and bigger and bigger. Is there a largest number? No. So they could just get huge. All right. Some of you guys are already zoning out. Stay with me, stay with me. This is not exactly what we're going to focus on today. I just wanted to answer the question. I went way too far. So into math, I'm always like, what's the answer? I want to know. And then you guys are all like, yeah, let me ask one more question. Are there other homework questions? Maybe I'll stop myself early this time.
21 on section A.
21. Oh, yeah. All right. This is one of the coolest guys in history. Does somebody know about? Let me see. Do I have it up there? 21. Yeah, it's there. Zoom in a little bit. There we go. I think you can stay there. Yeah. Ramanujan observed that the taxi number was very interesting because it was the smallest counting number that could be expressed as a sum of cubes in 2 different ways. Ooh, yeah, look at all this stuff. Ooh, dude. What, and again, this is going to lead into our lecture because we haven't even specifically talked about these things yet. But what is this kind of a candidate for trying?
Guess and check.
Guess and check. Guess and test. Whatever it is. Yes?
I just want to say I got one of the thingies. I don't know what they're called. Equations.
Yeah.
I couldn't figure out another one.
Okay, that's fine. A lot of the homework is going to be kind of like that, and that's where I come in and help. And I almost said blush. And the more work you show me, the easier it's going to be for me to help you go the next step, because it could be I could explain it from the standpoint of how you're already thinking about it. But again, if you turn the homework in and you don't have every single problem done and you have question marks, that's beautiful. There's nothing wrong with that. Just not question marks on every other problem, maybe. Don't turn that in. Maybe get some help. Okay. Anything else before we, yes?
What does, on the timeline, what does E50 mean?
Oh, yeah. Do you remember? I'm pretty sure I pointed it out. E50. Every fifth one.
Every fifth one.
Not every fifth odd.
Like 5, 10, 15.
Yeah, there you go. Yeah.
So this is for A.
Oh, okay.
At the top of the homework sheet, don't I have examples?
Yeah.
Okay. I'll never forget the kid that did I had E30, did every third odd. I was like, that was quick, Jeff. And I'm like, yeah, man, you did not do every problem. You guys understand every third odd would be whack. Okay.
How do we do number 6 exactly?
Back here.
Yeah.
Oh yeah, I know you guys have seen this kind of thing before,
Yes.
right? Yes. Don't tell me the answer. What do you got? What's the question?
Like, how do we figure it out? How do we make sure it gets into 13?
That's the whole thing. That is the entire point of this section, of the chapter really. The entire point is, so let me do this. I'm going to transition into lecture so we can talk about some of the methods we can use, right? What was I going to say? So a lot of this section is figuring out which method is going to work best, and then applying them. Okay, so some of them might be guess and test, right? There's some other methods we could use that we're going to go over now. Okay, but has anybody seen that kind of problem before? I'm sure you have, right? Has anybody seen that silly one with like 1 pen, 2 pens, 3 pens, 4 pens, and like move 1 pen to make it go the other way, 1, 2, 3, 4 the other way? All right. Anyway, all kinds of weird ass math. Facebook and stuff always makes me angry. I don't know if I told you guys that about the PEMDAS.
Yeah.
No?
Oh yes.
Yeah. All right. So let's kind of focus on, let me start lecturing a little bit. I'm going to transition to that. There's a dude, let me make sure I'm somewhere good. Okay. George Palia, who came up with the standard 4 steps for trying to do any word problem or any problem solving that you have to do. It doesn't even have to be a word problem. So there's 4 steps involved. I kind of said the first step the other day because somebody beautifully said, I don't understand what we're trying to do. Yeah. Which is a great question, right? So the very first step, which kind of makes sense, is understand the problem. It seems very basic, right? And good luck reading what I write. Actually, I had a teacher that wrote worse than me. And when somebody said, what did you write in number 1? And they were like, I don't remember. Does somebody remember what that was? Like, that's when I'm going to retire, is when I can't read my own writing. Understand the problem. So if you don't even understand what you're supposed to be doing, all right, that's pretty obvious. You got to understand what they actually want from you. Second thing is devise a plan. So I'm going to show you in a minute possible strategies to use. So the devise a plan could be draw a picture to start with. It could be guess and test. It could be, and actually there's a few different types of guess and test we're going to talk about. Okay, I like it. Now, remarkably enough, what do you think you do right after you figure out a plan? Do it, right? So carry out the plan. That's crazy. And then step 4, they call it look back, which normally is the old check your answer, right? But it's also look back. I always loved it when I would give a word problem to my algebra students. They would do the math. And they would tell me that the length of the shed has to be -7 feet. And they would just circle that bad boy and they just keep going. I'm like, stop and think, what is that shed made out of? What is going to happen to somebody who comes next to your negative length shed? Am I going to get absorbed into it? Is it a black hole? What? Right? So this is, not even that. It's like, how old is Sally? Well, I did the math and she's 927 years old. Does she live in that shed? What's going on here? This is all right, sorry. Does everybody, you guys have seen it before.
Yeah.
Just making sure the freaking answer makes sense in context of the problem, right? Talking about, let me do this. Let me throw up here, not throw up, but put up here some of these strategies. Oh, where are you? No, I didn't want to do that. Go. Hold on, guys. Open up. I might as well just put a book up here. I thought this would be easier. Okay, here we go. Where are you? Let me just put the book up here before we go crazy. So in your book, they actually list out, they have these 4 steps from George. And then, here's why I didn't want to put this up here. Oh yeah, it's already there. Let me see if I can do this. So down at the bottom here. Let's see, can you guys see that? So there's our guess and test. Sorry, it's so shitty, but draw a picture, use a variable like we did over there, right? Look for a pattern that's going to come up. That's the old problem, like 1, 4, 7, 10. So if I had the numbers 1, 4, 7, 10, what's the next number?
13.
13, right? The whole thing about finding a pattern. Make a list of possible answers, make a list, solve a simpler problem. That sounds weird. I do this all the time, and my students never quite understand that it's not cheating somehow. But like if somebody said, George has $8,228, and he wants to give equal amounts to his 4 friends, and they're like, I don't know what to do. Well, what if you had $20 and you had 4 friends, right? How much would each of you get? You know, that's what it means, a simpler problem. A lot of the times it's just making the same problem with easier numbers, because your brain kind of latches on to those smaller numbers. Yeah. And then you go, what did I just do operation-wise? I'll do the same operation to the freaky-ass numbers. Draw a diagram, obviously. Direct reasoning, indirect reasoning, we'll talk about that. Properties of numbers, that's kind of vague. Solve an equivalent problem, that's sort of like solve a simpler problem. Work backwards is nifty. We sort of guess an answer and see if it kind of connects with the beginning of the problem. Use cases, I have no idea what that means to be honest. Solve an equation like we just did over there. All right, so thank God we're not going to actually go through all of these. But just to give you an idea of what does exist. Look for a formula, do a simulation. A lot of these are very repetitive. Then you start to get, use a model. That's basically what that is. That's a model. Dimensional analysis. What the hell is that? Has anybody taken science course? Yes, you all have, yes. What was the big thing in science class that if you forgot it, your teacher would go a little mad, a little crazy? Units, right? Aren't units huge? Because you don't want to give the patient 8 tons of something. Probably mean 8 micrograms maybe or something, right? Dimensional analysis very often is kind of related to unit analysis. To make sure, dimensional analysis is sort of like if you're talking about area, you don't want to end up in cubic feet, right? Identify sub-goals, that's kind of funny. It's sort of like a multi-step problem. Coordinates and symmetry are kind of geometric. Okay, I like it. So let's focus on a few of those. There's way too many to talk about. Let's focus on a few of those. Yep. So here's my different possible strategies that section 1 talks about at least. Oh shit. All right. Oh yeah, so I want to talk about guess and test is my first one. Yeah, I'm always going to try to write check, but I won't. Guess and test. There's something called random guess and check, guess and test. Which, I mean, it's sort of like, do you see how this wasn't really random? If we would have kept going, what would we have guessed next? A bigger number, so it's not completely random. Wasn't there a system to what we would have done next? Right, didn't we have a system set up? So we guess, we'd see that it's too small, guess something bigger. What if we guess something bigger and it's too big? Then you guess something small. So there's a system to our guesses, right? So incredibly enough, there's a next level above random, and it's called systematic. And that's basically what I just said. Is there a system to the guesses you're taking? So that you're not completely randomly just taking any number that you think of. And then the highest level has got the freakiest name, inferential. This one obviously would involve a little bit higher level thought. I'll show you an example of a problem we did last time. Remember the one with the circles making a triangle and you had to put the numbers in them so they added up to be something or other? Let me show you that real quick. Here's an example of inferential thought, inferential guess and check. So here, they say, here's one approach to inferential guess and check, guess and test, whatever the hell it is. Start by assuming that 1 must be in a corner, and then explore the consequences. right? So here's where they start to, if I put a 1 here, then this must add to be 11, and this must add to be 11, because they were supposed to add up to be 12 altogether, right? It's wherever the heck it is. I think it was, okay. Obviously 12. You guys, let me stop for a minute. So there's not just guessing and running with it, but it's guessing and then seeing the consequences, seeing the implications of that guess. So then you say 2, and you're like, now why is this die immediately? Can you see why? Do they put it up there? So you're supposed to use the numbers 1, 2, 3, 4, 5, 6. Why would this kind of die immediately?
Because the only numbers that create 11 are 6 and 5.
6 and 5, and then there's nothing left for that. Exactly. All right, so do you see the kind of levels? 1 is completely random. 8, 2, 7, 3.7, 14. It's like, holy shit, just nothing. The next one is sort of like a little bit better. 8, too small, bigger, okay, right? And then this guy is sort of like, take a guess, think about the whole problem before you do it all. Does that, I don't know if you guys are with me at all. So that's the inferential level of guess and check. What's really, really neat for you guys, we're gonna see videos throughout the semester of students actually trying to work out a problem. And it's really neat to watch them even before you tell them anything about how to work the problem out, just what comes naturally to them. And what kills me is, and none of you guys are gonna do this to anybody, is that a lot of times early math teachers squash that creativity by requiring them to stick, and they don't even, I'm not saying all teachers, but there are teachers that if you did it a different way than what I showed you, that's wrong, it's all wrong. And then the student's like, I thought I understood something. And those are the people that go on to hate math, right? And then another example of a strategy is draw a picture, of course. Draw you picture, Jeff. Draw a picture. And then the variable thing. These are the 3 big ones that come up a lot. Oh shit, I love it. You guys are a little too polite. Go ahead, feel free to say, hey man. Obviously those have already come up. All 3 of those have already come up. Those are the main 3. Okay. So what I want to try to do, I've got a copy of something nifty. Let me see if I want to let you guys try it. Yeah, why not? Okay, this will be. What sucks about the way things are right now, I want you guys to try to work together, which is difficult with the way things are. But maybe, and this means you're going to have to get up and move. I'm really sorry. Maybe you could take your group to a certain corner of the room. Let's see how I want to work this. Sure.
Is it?
Yeah, I did all of them.
How many people are we
There's
interested
2, 4, 6, 8,
Oh, okay.
10, 12, 14, 16. Neat. So we can have 4 groups of 4. I like it. Do you want me to count off?
Yeah.
And then put people in 1, 2, 3, 4 groups like that?
Sure.
Yes? Okay. All right, here we go. You all love when this happens. You're 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, sweet. So why not all the ones over here? So she's all happy. She didn't have to move at all. She's like, ah. And then the 2's back there, maybe. The 3's up here, and the 4's back there. I love you guys. Some of these are going to be a little weird. Just be ready for that.